Hello, welcome to 2.3. So 2.3 is going to be a really big chunk of just algebra just in one big go. It's kind of a non-stop thing. So um yeah, we'll get into it, just try to crank it out, I suppose. So first thing we're going to talk about is function notation and evaluating functions. So um function notation basically is just like instead of writing y, you write f of x. So I could write like the function you guys are looking at on the screen now, like this one, I could write it as y equals negative 4x plus 7. But function notation writes it instead of y equals as f of x equals, which the reason for that is it's it's a little bit more, I don't know, I want to say professional, I guess. Um, it's basically saying a function of x. So this is a function with x as the variable, and that's essentially what f of x is saying. It's kind of like giving it a name or a category or something. But that's what it is. This doesn't mean anything really, like it's not a mathematical, it's not like f times x or anything like that. It's simply just a different way to write y, and we just call it f of x. Um, so it's kind of like its own variable. So, sometimes people look at it, think it might mean like it's f times x, but that's not it at all. It's simply just a way to say a function of x. Um, so that is what function notation is. And so starting with the first example, you can see an equation written in function notation. And it says evaluate it when x equals 2 and when x equals negative 2. So put it simply, we're just, you know, setting the function or setting x equal to 2, and we're just plugging it in. So when you see the notation here, you can see how f of x changes to f of 2. Again, what this is saying is that you're going to take the function and you're putting 2 into the function. So that's kind of the name or title, if you will, right? It's not really a variable. Again, this essentially tells just y equals. But you put the 2 here to say, I'm taking the function, I'm putting 2 in the function. And so this is you putting 2 in the function. You had x, you're plugging the 2 in for x. So it's just plugging in the number, right? Negative 4 times 2 is negative 8, and then you add 7 and you get negative 1. So f of 2, or the function evaluated at 2, equals negative 1. So if I wrote f of 2 here and said f of 2 equals negative 1, I'm simply just saying the function evaluated at 2 equals negative 1. And same thing, really, when I plug in negative 2. I'm just plugging in negative 2. And at the end, I'm saying my function evaluated at negative 2 comes to 15. So it just means I plugged in negative 2 and it came out to 15. So that's essentially, these are just plugging them in and then writing out our answer, but getting used to the notation. And it doesn't just have to be f of x, it can be g of x, it can be h of x, it can be whatever. The f, the g, the n, they are just basically names for the function. So just to distinguish them from one another. Because if I said, hey, plug negative 4 into f of x, um, then out of these three, which one you're plugging into, right? You're going to plug it into f of x. If I said plug it into g of x, well, again, you know which one to plug it into. So it's kind of the f, the g, the n. It's just really kind of the name of the function so that you know which one we're talking about. But in this the self-assessment questions here, you're simply going to evaluate each function for these three values of x. So basically, long story short, you're going to be plugging in these three numbers for the function. So like for f of x, if I plug in negative 4, f of negative 4, I'm going to do 2 times negative 4 plus 1. And so when I evaluate that, 2 times negative 4 is negative 8, and then negative 8 plus 1 ends up at negative 7. Right, and so then I'll plug in 0, so f of 0. So again, same function, right? 2 times x plus 1, but I'm plugging in 0 this time. So that's going to be 0 plus 1, which ends up as just 1. And then finally, I plug in my last one, which is 1/2, f of 1/2. So 2 times 1/2 plus 1. 2 times 1/2 is 1, and then 1 plus 1 is 2. So the outcome there is 2. So my three answers are these numbers here, -7, 1, and 2. And we're doing that for the other functions as well. So for g of x, plug in -4. So we'll have negative and then -4 minus 1. So be mindful that you see the negative in the function, but we're plugging in a -4. So the negative part of the function is still there. And then when I plug in -4, I'm plugging in a -4. So you can see that there's a double negative on this one. So that comes out to +4 minus 1, which will be 3. So just filling in the other ones, we'll plug in 0 next. -0 minus 1. -0 isn't really a thing. It's just 0. So 0 minus 1 is -1. And then I plug in 1/2. So this would be -1/2 minus 1. So essentially -1/2 will just be -1/2, and -1 would be -3/2. So -3/2, also -1.5, same answer. And then one more time with n. So n, plug in -4. So this would be 1/2 minus 5/6 times 4. This one's gonna come out to, this one's a little bit tougher. So this would be 1/2. 5 times 4 is gonna be 20. So this would be -26. And so a common denominator would be 6. This would be 3/6 minus 26, which comes out to -3 minus 20 would be -17. So -17/6. N of 0, if you plug 0 into the function, that's actually going to be pretty easy because, well, 5/6 times 0 would just be 0. So you'd have 1/2 minus nothing. So it would just be 1/2. And then finally, if I plug in 1/2 to the function, so 1/2 minus 5/6 times 1/2. So for multiplying the fractions, let me kind of zoom in on this if I can. I don't know if it's going to help or not, but for multiplying the fraction, 5/6 times 1/2, just multiply the numerators across and denominators across. So I have 1/2 still, but 5 times 1 will be 5, and 6 times 2 would be 12. So that'd be 5/12. So if I make a common denominator of 12, this would be 6/12 minus 5/12, which comes out to 1/12 as a final answer there. All right. So I did those a little bit quickly, but again, they are just kind of plugging in the numbers. So calculator can help for sure, but ultimately, just plugging in the number. Example 3. So this is the same thing, a little different because we're going to be plugging in the number in a different place. So as in this example, you can see there's your function h of x. It's 2/3 x minus 5. It says find the value of x for when h of x equals -7. So the difference here is we're plugging in -7, but we're not plugging in -7 to the x. We're plugging in -7 as the y, essentially, right? The h of x, our y value, so to speak, is going to be where we put the -7. So it's the same process, really, but kind of put it in a different place. 1 second. Okay, anyway, I'm doing this after school, as you can see. So you can see they plugged the -7 in for the h of x part where the y is, and then they're solving for the actual normal x value. So what you would do here is you'd add the 5 to both sides. They say that here. So if you add 5 to both sides, then the 5 would cancel out, and adding the 5 to this would make it -2. And then you're going to multiply by the reciprocal, so the multiply by 3/2. That cancels out the dividing of 3 and the multiplying of 2. So you take this, you multiply it by 3/2. 3/2 times -2 is -3. So your final answer there is -3. So it's very similar to the first examples, except we're plugging it in for the y value rather than plugging it in for the x value. All right, and then graphing a linear function. So one thing you can do is just pick a set of points and plug them in. So for example, you can see that they've already made a table for you, but on your own, what you would do is make your own table. And so I would recommend that you use numbers -2, -1, 0, 1, and 2 as the x values that you'll plug in to the function. It doesn't have to be those numbers. Technically, these can be any numbers you want them to be, but typically, again, this is what I recommend, and you can see that's what they've used as well here. So plug these numbers in to the function and see what we get. So if you plug in -2, you'll have to this function, you'll have 2 times -2 plus 5, which comes out, that's -4 plus 5, which is 1. So you can see there's where they get the 1. If you plug -1 into the function, 2 times -1. Oh, come on. Okay. The pen's died on me. Oh, give me 1 second. All right. So my pen decided to not work anymore. So I'm going to see, I'm going to figure out how I can do this. I know I could use my mouse pad, but it's not very nice. But anyway, you plug in -1 to the function here, you add 5 to it. And so this would end up being 2 times -1 would be -2. And then you add 5. So -2 plus 5 would be 3. And so there's 3. And again, you can see that's how they get it here. I won't do all of these just to save time, especially now that I don't have my pen. It's going to take me slower. But you get the idea. Next one, you would plug in 0. You'd have 2 times 0 plus 5. 2 times 0 is 0. And then 0 plus 5 is 5. So you can see where they get those numbers from. So you would just make it yourself, though, pretty much is the thing here. They wouldn't have a table. You just have to make your table yourself. And then you just plot those points. So -2, 1 is a point because you plug this in and you got 1 as the output. So -2, 1 is a point. So you'd go over -2, 1, and you plot that point. You can see that point right here. Then you have -1, 3 as another point. So -1, 3, and you plot that point there. 0, 5, plot that point there. 1, 7, and then 2, 9. If you plugged in 1 and you plugged in 2, you'd get out 7 and 9. And then you've plotted the points. You're like, all right, I can see the pattern here. So you draw the line through it, connecting all the points together, and you've made your line just like that. So for number 5 and 6, same story. You're going to plug in the 21 as essentially the y value. So this would be, let me see if I can get this in here nicely. Oh boy, 21 as the f of x equal to 6x plus 9. You can tell I wish I had my pen working. It does this sometimes. I usually will pause the video and make the second one, but I'm kind of in it now. All right, so anyway, you plug the 21 in. And you solve. So you'll subtract 9 from both sides first. So minus the 9 will cancel this 9 out. So I'm trying. Oh, there is another way I could do this, but apparently not. Okay. Yeah, so minus the 9 on both sides. 21 minus 9 is going to be, what's that, 12? So this would end up as 12 equal to 6x. And so then you, of course, divide by 6. And you're going to end up here with x equal to 2 when you're done. Because 12 divided by 6 is equal to 2. All right. Oh, boy. It's not brilliant. Again, my pen doesn't work. Oh, I hate it. All right. So what I'm going to do, I'm pause the video here, stop it, restart this, and then carry on with the second video so you guys can really get this properly, because it's not going to be good if I just do it this way. So I'm going to stop it, make a second video, and you guys pick up there. Okay. Bye for now. See you in the next one.